Video, we're going to learn how to do grams to grams stoichiometry. You should have this packet, which is the exact same. It has pages of templates we're going to go through, and you're eventually going to glue it into your notebook, page 108. I made some mistakes on here, or I photocopied the wrong one. So in the regular class, we were using given and need, and I photocopied that cover. So wherever it says given, I want you to change it to known. That's what we've been calling it. It really is the same thing. And grams of need is the unknown. All right, so these directions are on the front of the page. The process doesn't ever change for grams to grams stoichiometry. The plan is always we take the grams of the known and we convert it into moles of the known, and then we convert it into moles of what we're looking for, the unknown, and into grams of the unknown. Each arrow is one conversion factor. Sorry.
Teachers and staff, there's a meeting in the media center for CCEA, and all teachers are invited.
The first arrow is going to be your atomic or molar mass of the known, and then you're going to do the molar ratio. So that is number mole A is equal to number mole B, and then we're going to do the atomic or molar mass of the unknown. The only thing that changes is the chemicals. So molar mass and atomic masses and molar ratios change, but that's it. So what we're doing here is mole island, right? So we're starting here because we're doing mass to mass stoichiometry. So we're starting here and we want to get over here. So we have to go from grams to moles of the known or substance A. We're going to use the molar mass or atomic mass, usually molar, to get to moles. Then we're going to use the molar ratio, and we're going to get the coefficients from the balanced equation to convert from known to unknown chemical, substance A to substance B. And then we're going to go to mass, and we're going to use again our grams to moles conversion factor, which is usually molar mass but could be atomic mass, to get the unknown grams. Alright, I have blown this up so I can write and you can see. If you open up, here's your packet, open it up. It didn't photocopy perfect. Sorry. So, you'll be right though. It's right here. You're going to fill it in as I fill it in. I just made mine larger so that you can actually see it. If I did it that small, you probably would not see it. Alright, step number one. Example number one. We have H2SO4, which is sulfuric acid, plus sodium hydroxide makes water and sodium sulfate. The question is, how many grams of water are produced if 2 grams of sodium sulfate are produced? So we want to know how many grams of this we're going to make if we make 2 grams of this chemical. Because it's grams to grams stoichiometry, the first thing we need to do is balance this chemical reaction. So I've left you some space to do that. We have a hydrogen on the reactant side. This SO4 is intact on both sides, therefore I can use it as a balancing unit. Sodium and hydroxide is polyatomic, but it's not in hydroxide form over here, so I have to do oxygen separately. On the product side, I'm going to make my same list in the same order. Alright, now I'm going to tally them up. I have 2 hydrogens here and 1 there, therefore I have 3. I have 1 SO4, I have 1 sodium, and I have one oxygen here because the 4 oxygens in SO4 I've already counted. On this side I have 2 hydrogens, SO4 I have 1, sodium I have 2, and oxygen I have 1. Alright, now we need to balance this. Alright. Well, because, okay, hydrogens are not balanced, but because hydrogens in 2 places on the reactant side, I'm going to leave that be. SO4s are good, so I'm going to move down to sodium. I have 2 on my product side, so I'm going to put a 2 in here and change that also to a 2. Now my oxygens are now 2, and I have 2 hydrogen here plus 2, so I have 4 total. Now let's take a look on this side. Again, the hydrogens are in 2 places, so I'm going to try to get the rest of this stuff balanced first. I'm going to start with oxygen, and I have 2 to 1, so here I'm going to put in a 2. That was a really ugly 2. There you go. Now I have 2, and that changes my hydrogens to 4. Ooh, looking good, right? I have 4, 1, 2, 2. Right, so it looks like I'm good to go. So in this area right here, just write in the actual balanced equation. That's what I'm asking you to do. So we have H2SO4 plus 2 NaOH yields 2 water plus an Na2SO4. Oh, we just did step 1. That's step 1. Step number 2, we're going to identify the unknown, the known, the unknown, and the conversion factors. Probably should not say unknown conversion factors. That seems strange. I have the right vocabulary in there, though. That's good. I'm going to have to make a few more corrections to this till I get it right. All right, we have to go back to the question to figure out the known and the unknown. So it says, how many grams of water are produced if 0.2 grams of sodium sulfite are produced? So the known is definitely in 0.20 grams. Now I got to figure out which one's sodium sulfate. That's sodium hydroxide, but this one is sodium sulfate, so Na2SO4. The unknown asks me, question mark, grams H2O. So now I've got the conversion factors. And these are the 3 conversion factors that I need to have. I need to have the molar mass of the known, the molar ratio, and the molar mass of the unknown, right? I need the molar mass of the known, molar mass of the known. I need to have the molar ratio, and I need to have the molar mass of the unknown. The exact same thing. Okay. So I left you some space to do that. And so the known in this case is going to be Na2SO4. So Na2SO4. I'm going to get the molar mass of that. So Na is 2, S is 1, O is 4, 22.99, 3206, and 1599. Hopefully you know where I'm getting those and what I'm doing. When I did this, I got 45.98. This one I can do just like that. And 63.96. I add that up and I got 142 grams per 1 mole. The molar ratio is going to be moles of Na2SO4 over moles of H2O. And I need to go back to the balanced reaction. I need to find out how many Na2SO4s. If I take a look, there's 1. So 1. And how many waters? I look and there's 2. So I put a 2. Molar mass of the unknown. The unknown is water. So I have hydrogens and oxygens. I have 2 and I have 1. The atomic mass is 2.0161599. Add it together and I get 18,006 grams, 1 mole. Now this is a suggestion. It's not mandatory, but if you write these as fractions, see how it's clearly a fraction? I have the many of grams over a mole. And then if I box them off, they're clearer. The students who do this for a while seem to be able to pull this stuff out faster. So those are my conversion factors. I made them fractions, and I'm boxing them off because there's extra work everywhere. That is step number 2. Right? I'm gonna do this because it's the same thing. I'm gonna do this for now. Oops, I'm gonna do this. Here we go, because it's the same. Ooh, fancy. I did it. Alright. Look, you can almost see everything. Almost. Come up a little bit. There we go. Alright. Oh, you don't need the top. That's what we need. This is step number 3. I'm going to use all the top information to do the bottom. These are all fractions that are going to be multiplied. Right. So it says change known to moles using molar mass, and it's the known. So I need to start with what I'm given. 2 grams Na2SO4. I'm not sure it's going to fit. Do my best. I might have to do it like this. Okay. Now that number is always over 1. Now I don't need this, so I'm going to come back down so it's bigger. There we go. Focus it. Alright, we need to use the molar mass of the known. Here is the known, here is the molar mass of it. Now I have grams here. Therefore, I need to put grams on the bottom. Grams. It's going to be the same chemical, Na2SO4, and the number for that is 142. The rest of the molar mass is 1 mole Na2SO4. I would start canceling right away. Grams Na2SO4 cancel, and I'm in moles Na2SO4. Right. Next thing that I'm going to do, I'm going to use the molar ratio to change into the unknown. This is the molar ratio. If I look here, it says 1 mole Na2SO4. So I'm going to put my mole Na2SO4 on the bottom, and there's 1 of them. And I'm going to put the 2 moles H2O on the top. Okay. I'm going to cancel out my like terms. And now I'm in moles of H2O. So the last step is to change the unknown moles into grams using the molar mass. And I have the molar mass right here. Moles on bottom. 1 goes with a mole chemical, and 18,006 grams H2O on top. I'm going to cancel out my like terms. I'm in the unit that I want. last and final step, which I'll fold this because this is the same, here we go, is to pick up my calculator and to calculate this. And we have to have it in the right number of significant figures. So I'm going to take the 2 times 1 is itself, divided by 142, and then I do enter, times 2, divided by 1 is whatever it is, times 18.006, enter. I have 2 significant figures here, so 0.51 grams is the only thing that's not canceled, H2O. So now if I start with 2 grams of, if I produce 2 grams of sodium sulfate, I'll also produce half a gram of water in this particular chemical reaction. We have just completed a gram-to-gram stoichiometric problem.